All right, we're going to begin today with another speed drill. So if you would open up your speed drill booklets to that first page. And we did speed test 1 in our last lesson. We'll do speed drill number 2 today. You'll have an extra 30 seconds for this one. We've got some adding, subtracting, multiplying, and dividing. As a reminder, you do not have to go in order. You have 3 minutes and a half to work, and you may begin. Don't sit there staring at me. Go. Stop. Pencils away. Get your pens out and exchange with the person behind you, person in the back. Bring yours to the front. Pencils away, pens out to grade. Exchange with the person behind you and person in the back. Pass yours to the front. If you would, sign your name as the grader next to where it says Speed Test 3. They're at the bottom of Speed Test 2. Sign your name at the bottom of Speed Test 2, right next to where it says Speed Test 3. And like last time, these are going to be 10 points each. I'll read each answer twice. Check it carefully. Again, if it's correct, don't make any marks at all. If it's incorrect, just put a slash. That way you'll be able to count up the number of slashes when we're done. Number 1, the correct answer should be 56,214. 56,214. For number 2, 2,262. 2,262. For number 3, 373,320. 373,320. That would have been one of the last problems I'd have done. I also might have flipped the two factors, so I could have put the 408 on the bottom and skipped the 0. Just some thoughts. Anyway, number 4, we end up getting 2020. 2020. 2020. Number 5 is 158. 158. Number 6, 104. 104. Number 7 is 791. 791. Number 8, 424,860. 424,860. Number 9, using 3 as your estimator, you should have gotten 54 without too much difficulty. 54, the answer to number 9. And number 10, cross out those zeros. It becomes 54 divided by 9 equals 6. 6 is our answer for number 10. All right, they're 10 points each. Figure the score to the best of your ability. Put it in the score blank. Yes, ma'am?
What if they put the comma in the wrong place? Like if it was a 4-digit number and they put it between the second and third number instead of the whatever.
Minus a point. I'm not going to mark it all wrong. Just minus 1 point if they put the comma in the wrong spot. Don't put the commas in the wrong spot, people. All right, 10 points each otherwise. And figure the score, put in the score blank. If you would, make sure you also then turn to that very first page where we've got a list of the scores, and where it says Speed Drill 2, put their score in that blank. Put their score for Speed Drill 2 in the blank next to Speed Drill 2. Then, person in the front, stand up, take it to the back. Everybody else pass it forward to the person in front of you. So that way everybody has their own Speed Drill booklet again. Does not require a whole lot of talking here. All right, any hundreds? Any hundreds on this speed drill? A little bit more variety to this one. Couple of you. You still waiting on your booklet? Ben, are you finished grading?
Yes.
Hand it back to Paige. Or to Paige. Hi, Paige. Hand it back to Kirsten. Kirsten, you have your booklet now. Okay. Any hundreds? Any hundreds on this? How about 90s? Just missed one problem. 80s? Just missed a couple. All right. Any questions on the speed drill? Yes, sir.
So we have to place the commas in the right place. Or we
Yes. Yeah. You don't misplace a comma. It's just minus a point, of course. We're not taking off all 10 for that, but yeah, don't mess up the commas. All right. Any questions? That was a good question. Any other questions on the speed drill? All right, pass the booklets forward, putting yours on top. So person in the back, hand yours to the person in front of you, and as they come forward, continue to place yours on top, so the first person in each row will have theirs on top. Once you've passed it forward, open up your textbooks to page 17. Open up your textbooks to page 17. On page 17, you did numbers 21 to 27 there in the homework section. Some basic review. Want to take a look at that. Page 17 to 27, 21 to 27 in the homework section. In addition, if you would, have that homework handout out. You didn't finish it, you just did the middle row, but you did one more row of division problems on the handout. There we go. So we've got the handout, we've got the 21 to 27. Good. There's the handout. And there's the 21 to 27. Page 17, quickly. There's the handout. And there we go. All right, good. And what happened here? Just really struggled to get it? All right, we'll go over it, but it looks like you made a good effort. And there's the division, and there's that. Excellent. Okay, went a little further than I wanted you to, actually. So you'll be a little bit bored as we're working later. Hopefully not too terribly bored. Good. Much better today. Excellent. Good. I know it's a transition. You're so used to, in elementary school, you've got a homework section clearly laid out for you. And so you can almost cheat the system and not write your homework down. You just kind of knew what the homework was going to be. And you're getting used to now in 7th grade, right? Having to write it down because you don't know what it's going to be. It's completely whatever I feel is the best thing for you that day. So doing better, much better. I think it's the first day we've all had it. Let's keep that up. Let's start by looking at the 21 to 27, and then we'll look at the handout together. Number 21, in which of those two numbers, we're on page 17, which of those two numbers does the 7 have the greater value? Michael?
From 27,593
Good, because it's worth 7,000 in that number. It's only worth 700 in the other number. Number 22, which digit is in the thousandths place? Paige?
3.
That's in the thousands place. And again, if you're not careful, that TH will throw you off. Which one's in the thousandths place for redemption?
The 9.
The 9, there you go, good. Number 23, which of those decimals is a greater value? Jalen?
10.29.
10.29 is greater than 10.229. What do we get on number 24 when we round to the nearest 10,000, Luciana?
63,420,000.
Good, I thought I might have heard an and in there. I couldn't quite tell. 63,420,000 is correct. Number 25, what would be the total cost to purchase 5 sandwiches that cost $4.38 each? Kirsten?
21.90.
How do we say that as money, though?
$21.90.
Perfectly said there, $21.90. Number 26, what's the difference of 5.95 and 4.7? Let's go to Corey.
1.25.
1.25 is correct. And the number 27, we hadn't really looked at this yet. I'm just curious to see how we did, because we're going to be looking at this in today's lesson. But you did read pages 8 to 9, so we should have been able to get these. Letter A. What kind of symbol did we put in the blank? Did we put a greater than symbol, a less than symbol, or an equal to symbol? Elaine, what'd you put in letter A's blank?
Less than.
A less than symbol. 2.54 is less than 2.55. How about letter B? What do we put in that blank? Sam?
Do we do a greater than?
Greater than. Negative 8 is greater than negative 11. I like to think of negatives as if you had to owe money. Right? You ever borrowed money from somebody and they hound you about paying them back, right? Okay. Would you rather have to owe somebody $8 or owe somebody $11? The less you owe, the better off you are. Negative 8 is greater than negative 11. And how about letter C? What do we put in the blank there, Bryson? 300 isn't equal to 3,000. Maybe you misinterpreted that comma as a decimal or something. I don't know if I know. What did you have in that blank there for letter C? Ben?
I had a lesser than. Or
Less
greater
than.
Whatever. A greater than.
Hopefully you had this one. This one's less than.
Yes.
300 is less than 3,000. Should have been our answer there. Questions on 21 to 27. Michael?
I have a question about 27A.
Uh-huh.
It's not on here, but could you put an approximate sign for A?
I mean, they are approximately equal. That wasn't one of their options. But I mean, you wouldn't be entirely wrong to say they're approximately equal to each other. But that wasn't an option. We were strictly looking at greater or less or equal. So, yeah, good question. Good. Other questions? All right, let's take a look at the handout. So set the book aside for just a little bit. Well, let's look at that handout together. And I'm going to give you the answers first, and then we'll go over any questions we have. I already know I want to look at the last one on this middle row. I think it was Corey was having a little trouble with it. That's fine, right? It's okay to have trouble with the homework as long as you're trying your best. And I could tell from all the erasing he'd done, he had been trying his best. He tried it a few times, as long as we learn from it, right? Because we don't want to struggle on quizzes and tests. It's okay to struggle on homework as long as you're trying your best. The first answer we should have had was 6.75. We needed to add a couple zeros, and that would have gotten us to 6.75. The next one, we only ended up needing to add 1 0 to get 3.75. And on the last one, we did need to add a 0 to get 6.2. Let me ask this first. Was anyone perfect on all 3? You got all of them right. Okay, a few of you. How many got 2 of the 3 right? Just missed 1 of them. All right. I know we need to look at the third one. Does anyone need to see one of the first 2? Yes, sir. The second one? Okay, does anyone need to see the first one? Okay, we'll work all 3 then. That's perfectly fine. Let's take a look at the first one. Then we get 162 divided by 24. And if I'm looking at this, look up this way, I'm going to ask myself, how many times does 2 go into 16? Class? 8. But it goes in perfectly 8 times, right? That 4 is really going to mess that up, isn't it? So I'm going to do 7 instead. I'm going to go over here and put 7, multiply, and I get 168. What does that mean, class? Even the 7's too big. Okay, no big deal. Instead of a 7, we go with a 6. Not a huge deal. I didn't take that long figuring it out. I just slap it down and see what happens, right? And then when I multiply, I end up with 144, which I can subtract to do a little borrowing and get 18. But I'm not going to leave this as a remainder. I'm going to add a decimal and bring down the 0 here. So Paige, let me ask you, did you start off with the 6 as the number you chose? All right, did you get an 18? Okay, so maybe a subtraction issue, kind of threw some things off then. Should have gotten an 18, bring down the 0. Now, how many times does 2 go into 18, class?
6.
9 times, right? 2 is an 18, 9 times. But remember last time we were a couple too big? Like we said 8, we're like, yeah, but it's going to be 7. Well, actually, it's going to be 6. Well, it goes at 9, but yeah, I would try 8. I'm going to go all the way down to 7 and see what happens, because I've lost faith. So we're going to multiply it. I just did it 7 a minute ago. Remember it was 168? Let's see what that subtracts to. Comes up with a 12. Okay, we're good. But I'm not done. Add another 0. Bring that down. How many times 2 go into 12? 6. But yeah, I know that ain't working because that's 144. So let's try 5 instead. And when you multiply, it comes out evenly to the 120, and that's where we get our answer. So again, just adding some extra zeros, bringing it down, but don't lose that decimal in the answer. Look at the next one. You had a 67.5 divided by the 18. Sam, what's our estimator on this one?
The estimator will be like 2.
A 2. So we're asking ourselves, how many times does 2 go into 6?
Like
3 times, right? And by the way, notice, we didn't have to pair any digits. Like that almost never happens. We didn't have to pair anything. 1, 2 digits, 1, 2 digits. We're literally going to put the 3 right here. When we multiply, we end up with a 54, subtract it to 13. Don't forget to put the decimal up above as well. Bring down the 5. How many times does 2 go into 13?
5? No,
If you had $13, there were $2 candy bars. How many $2 candy bars could you buy with 13 bucks? 6. So let's try 6. And we multiply, and let's see, I think this comes out to 108. And we're like, that doesn't look very big, right? So I'm like, I bet I could get another one. I haven't even done the subtraction, but it doesn't look right to me. So I'm going to try a 7 in here. And then we multiply, and that looks a little bit closer. We do our subtraction, get a 9, but I'm not done. So we've got to add another 0. Well, add a 0, it's the first one in this case. Bring it down, and we're like, how many times 2 go into 9? Again, $2 candy bars, you got $9. How many you buy?
you buy like
4. But remember last time my number was too small. I'm gonna, just try. Let's see if 5 works, right? 4 definitely would work, but maybe 5 could work. Let's just give it a try. Sure enough, it works out evenly, and there's our answer. That make sense? All right, and then for Corey, looking at the last one, we had a 155 divided by 25. And again, I like to think of quarters, right? How many quarters would it take to get into $1.55? $25.50, $75, $1.25, $1.50, right? So we could fit 6 of those. That's your $1.50. Still leaves you with 5, but I'm not done. So I've got to put the decimal and add an extra 0. And then how many quarters in 50 cents? And we're done. Does that make sense? All right. A couple more problems. If you would flip that handout over to the back side. I want to look at a couple more problems with you, and then I'm going to have you finish the handout. I did want to look at just a couple problems with you. Write this on the back side of your handout. 645 divided by 2.7. 645 divided by 2.7. Something kind of interesting happens in this problem. Right off the bat, though, I've got a little issue. I can't divide, class, by a decimal. So I've got to move the decimal out of, what do we call this again, class? The divisor. I've got to move it out of the divisor by moving it one place. And if you move it in the divisor, class, you also have to move it in the dividend. But I don't see a decimal in the dividend. Class, where is it?
At the end.
At the end. And when I move it, it creates a gap that must be filled in with a 0. So I've made this basically 6,450 divided by 27. What's my estimator going to be here, Ben? 3. A 3. I'm going to ask myself, how many times, Paige, does 3 go into 6? How many times does 3 go into 6? 2. So we're going to count over the 2 digits. We're going to put our 2 here. Anybody figure it out real quick? 2 times 27?
5.
So 54. We'll subtract 64 minus 54.
10.
10. Is that smaller than 27?
Yeah.
Okay, good. We'll bring down the 5. And how many times does 3 go into 10, class? 3 times. And 3 times 7?
21.
21. Carry the 2. 3 times 2 plus 2? 8. And we subtract, and what do we get?
24.
24. Ooh, just barely made it, right? And but we're not done, right? We've got to bring down the 0. And by the way, the decimal's now here. So this isn't the decimal up here anymore. It's back here. We moved it. Don't forget that. How many times does 3 go into 24, class?
8.
8 times. 8 times 7?
56.
56. Let's carry the 5. 8 times 2 plus 5?
21.
21. And we subtract, do a little borrowing. What do we get?
14.
24. Well, we aren't done. We would have to add a 0, right, and bring it down.
Oh, no.
But it's another 240. What's going to keep happening, class? I'm going to keep getting 8s. Now remember, how do we show that a digit repeats, class?
You put on
Put a bar, but you can't do that until after the decimal point. So I can't put a line over this 8. I've got to go ahead and write one more 8 so it's after the decimal, then put my line. Does that make sense? So it doesn't repeat until after the decimal point. Questions on that problem? All right, one more for you to put on the back of the handout. One more problem for you to get down just for illustrative purposes. Write this down, 6.8 divided by 0.11. 6.8 divided by 0.11. First thing I've got to do right off the bat, Luciana,
Move the decimal.
move the decimal how many places?
Twice.
Twice. So we're going to move 1, 2, and then here I move 1, 2, and this number becomes what, Luciana?
680.
680. There we go. So I'm going to put the decimal up here and down there. And we know our 11 times tables, right? So I don't need an estimator. I'm going to use the whole 11, class. How many times does 11 go to 68? 6 times, what is that? 66. So how many left over? 2. I'm going to sneak the 2 right there. I'm going to do short division with it, 11. How many times does 11 go into 20, class?
Once.
Only once. And that's 11. What's 20 minus 11? 9. I'm going to add an extra 0 and put my 9 there. How many times does 11 go into 90? 8 times, because that's 88, right? How many left over? 2. So I'm going to add another 0, put a 2 here. How many times does 11 go into 20? 1. Do you see what's about to happen? Goes in once, that's 9 left over. How many times does it go into 90? 8 again, then it's going to be 1 again, then 8, 1, 8, 1, 8, 1. How do I show that both digits repeat? Jalen?
Double bar.
Put the line over both digits. And there we go. So if you have multiple digits that repeat, you'll do that. By the way, something interesting, I'm going to show it real quick. Anything over 7 is kind of interesting. When you divide by a 7, you end up with, I'm going to show this real quick in quick time. 7 into 40, class?
5.
5 times with 5 left. 7 into 50? Class?
7.
Thank you. 7 with 1 left. 7 into 10, class?
1.
1 with 3 left. 7 into 30?
4.
4 times with 2 left. 7 into 20? 2. Will this never end? With 6 left. 7 into 60? 8 with 4 left. 7 into 40 is going to be that 5. Then another 7, then another 1. And all 6 digits repeat. Anytime you have sevenths, anything over 7, you're going to get a 6-digit, what's called a repetend. Okay, so I'm not going to throw most of that at you in 7th grade math, but just wanted to show you can have lots of digits repeat. Sevenths is a really easy example to show with that. So kind of interesting there. All right, I want you to finish the last row now on that handout. Sit nice. Last row on the handout, finish it up, and then we'll take a look at that. Finish up that division handout. Once you got all three finished, pencil down, and look this way so know that you're done. Those zeros until it finally stops or until you see it repeating. Either one. If you need help, raise your hand. I'll come by and help you. Actually, you're doing pretty good here. Because when you subtract, what do you get? Careful. 12. Which one you add another 0? Gives you another 120, which we've seen that before, right? So it's going to go back to what digit now? 5. Back to a 5. And just gonna keep it. Yes, sir. That's why. Yeah, a little bit of issue here. Let's say -4. Right off the bat, creating issues there. What's 7 minus 4? Oh, so your subtraction's killing you. Good, Corey. Careful, Jalen, you read into something that wasn't there. There's a 12 left over. Bring down a 0 and do it and keep it going. So the 9 doesn't repeat. There's a different digit after that 9. Finished. Let's see your answers. Oh, 12 minus 5 is 7, not 8. So right off the bat, got it. Thanks, screwy on yourself. Excellent job, Ben. Perfect. If you're trying to do all that work, all you gotta ask yourself is how many times does 3 come into 16? And then multiply that. You tried every other number in the book and just use that first digit type division check with the estimator. There you go, except that one doesn't. It's just those two with that. Pencils down for just a moment. I'll let you resume working in just a second. I want to go over the first one with you. Most of you are finished by now. Most of us got the 4 to get 88, leave us with 6. 2 to go into 65, 44 leaves us with 21. Most of us got the 9 to leave us with 12. Brought down to 0 to get 120. Got 5, which is 110, leaves us with 10. Bring down to 0, goes in 4, which is 88, leaves us with 12, and you're bringing down the 0. Remember the last time you got here, you used the 5 to subtract 110? Those last 2 digits are just going to keep repeating. So 42.9, 5454545454, right? And so don't be too early, too quick to try to call the repeating digit. Make sure you know it's repeating. Even if you take the time to actually work another 5 and then work another 4 and then it hits you. Wait, they're going to repeat. That's okay. Then you just go back and hit that line and scribble it off, right? But don't be too early to call the repeating digit. How many got that? All right, continue working. Continue working. I'll leave that up there for you. All right, most of you are also done with the second one. No repeating digit this time, right? Works itself out just fine. 2.125. Yeah, we had to add a few zeros to get to the end. How many got 2.125? All right, if you're good, finish up the last problem. Any questions on that second one? All right, finish up. I'm going to erase this problem now, and then I'll work the last one. And I know many of you haven't finished the last one. That's okay. Check the work up here. End up getting 116, and I realize I'm going to get another 6, and it's just going to keep being 6s. So 116.6 repeating. How many got it, or you were at least on the right track? Sit up, Michael. Got it or on the right track? Questions on that last one? All right, at this point, we've looked at all the weirdness that could happen in a division problem. Good news is that kind of weirdness isn't going to happen all the time, but I wanted to make sure that any weirdness that you saw, whether it's annexing zeros to finish it out, whether it's crossing off extra zeros, whether it's having to use an estimator versus the first digit, wanted to make sure you got a chance to see all of that. All right, set that handout aside. Open up your textbooks to page number 8. Set the handout aside. Open up your textbooks to page number 8. And you read pages 8 and 9 last night. Wanted you to kind of preview what we were going to talk about in the lesson today. Different types of numbers. And there are different categories of numbers. But the first group of numbers is what are called counting numbers or natural numbers. Do you see how in your textbook it has counting numbers in bold on page 8? Everybody look on page 8. See how it says counting numbers in bold? Do you see how just a few words later it says natural numbers in italics? Would you go ahead and underline those words to draw your attention? Or maybe if you have a highlighter, highlight them. Natural numbers. These are the numbers that you, or maybe your mom, would naturally use to count. Let's be real. How many of you can relate to this one? Jalen, get down here right now. 1, 2, 3. How many of you are like, yep, that's been me before? I mean, except I haven't been called Jalen, other than Jalen. All right, okay, so y'all been there, right? Natural numbers. Now, how many of you, just to be nerdy at times, be like, 1, 2, 2.7, 2.75. Okay, I've got a few nerds in here, but that's not natural to count that way, is it? That's why we call them natural numbers or counting numbers. They're the first numbers that naturally come up. Now, there's another number that nobody uses when they count, right? It's never, Ben, you better get down here right now. I'm counting 0. 1, 2, nobody starts at 0, but I mean, 0 is kind of like the other numbers. It's just not as natural, but it's still what we call a whole number. So if you just use 1, 2, 3, 4, etc., those are your natural numbers are your counting numbers. Whole numbers include all of those, but they also include 0. So these are whole numbers. Does that make sense? 0 is a whole number. These are also called counting numbers. Does that make sense? So just like we are in Columbus, we are in Georgia. Georgia, Columbus. It excludes something. There's other parts of Georgia that aren't Columbus. We happen to be in both. So 1, 2, 3, 4, blah, blah, blah. They fall into both categories. 0 gets to be considered a whole number as well. Does that make sense? But then we have another group of numbers, though, that you learned about last year for the first time, I believe. And those were numbers that are actually smaller than 0. You spend money you don't have. The thermometer drops. Now, in Georgia, this never happens, but how many of you have lived up north at some point in your life? You've lived, I know you've lived in Michigan, you lived Colorado, Washington, D.C., or Washington State? Washington, D.C. Up north, it is not that uncommon in the wintertime for temperatures to drop 5 degrees, 4 degrees, 3, 2, 1, 0. Now, 0 doesn't mean there's no temperature. It's just a point of reference. But then the temperature can go below 0. And we call those numbers, class, negative numbers. Now, again, can you have numbers like 2.8 or 2.9? Sure. We don't like those numbers, though, right? 7 and 9/8, what are 9/12? We don't like those numbers, right? But we could have -4, -3, -2, -1, 0, 1, 2, 3, 4, right? Just like we have natural numbers, we could have the natural numbers that are on the negative side. This group of numbers are called integers. Integers, and this is a new term for you, so make sure you put a star next to that term in your, actually, is that in your notes? Yes, it is. It is in your notes down there just above table C. Do you see that term, integers? Integers include only whole numbers and their opposites, which are the negative ones. Make sure you know that term. Integer just means nice, easy numbers that could include negative values. So, question, is 2 an integer, class?
Yes.
Is it a whole number?
Yes.
Is it a natural number?
Yes.
Is 0 an integer, class? Is it a whole number? Is it a natural number? Make sense? Okay, is -3 an integer? Is it a whole number? So is it a natural number? No. Do we see how these different layers work? There are numbers that can fall into multiple categories. So basically, if we were to draw a number line, you might have seen this last year, we're going to use as the reference point, the middle point of the number line, the number 0. And we refer to 0 as the origin of the number line. You'll see that term nowhere, right in the side margin of your book at the bottom of page 8. Write that at the bottom of page 8, off to the side. I'm trying to figure out where that term origin is, and I'm not seeing it. So go ahead and write that down if you would. 0 is called the origin of the number line. It's kind of the dividing point between everything big and everything small. You need to know that positive numbers are anything bigger than 0. Anything bigger than 0. Those are positive numbers, right? Just like positive temperatures are temperatures above 0. And of course, then negative, class, would be numbers that are
Negative, below 0.
smaller than 0 or below 0. Let's say smaller than 0. Smaller than 0 are your negative numbers. Now here's the deal. You've got these big numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It just keeps getting bigger and bigger and bigger and further away from 0. Well, think of this for just a minute. It's kind of weird to our thinking, but -1, -2, -3, -4, -5, they keep getting smaller, don't they? So that if you saw a -12 here and a -3 here, -12 is smaller than -3 because it's further to the left. The further left you go, the smaller it gets. The more negative, but the smaller. The further to the right it gets, the more positive it gets, which means the bigger it gets. Does that make sense? All right. Now, with this idea of numbers getting bigger and numbers getting smaller, we also have this idea of how far away is a number from this origin point, Jalen, focused up here, of 0. Well, how far is -3 from 0? Well, if we were to count, class, -1, -2, -3. That's 3 units away. But what if I asked about 3? How many units away from 0 is 3? 1, 2, 3. It's also 3 units away. It's in the different direction, but they're both 3 units away from 0. We have a term that refers to distance away from 0, and we call it absolute value. I think you see that on page 9. Absolute value is a number's distance from 0. Mark that, maybe with your highlighter or your pen. The distance of any number from 0 is its absolute value. And we show absolute value by using this notation, a couple of long parallel bars. And whatever you want to take the absolute value of, you put between. So the absolute value of -3 is 3. If I want to take the absolute value of +3, that's also 3. They have the same absolute value because they're the same distance from 0. They're just on different sides of the 0. Questions on that? Questions on that? All right. Let's take a look at some exercises here. Bottom of page 9 now. Bottom of page 9. And they've got a little chart here on numbers 1, 2, and 3. Why don't you put a little X in all the different columns that pertain to these different values. So let's start with number 1, 112. Is it a counting number, class? Now, your mom better not get to 112. I mean, that would just be, I don't think a parent would ever let you get to 112. But it is a counting number, isn't it? So put an X under it. Is it a whole number? Because all counting numbers are whole numbers, right? Is it a positive number?
Yes.
Yes. The fact that you don't see a negative sign means it's positive. Is it a negative number? No. Is it an integer?
No.
Yes. Integers refer to anything that doesn't have fractions or decimals. Here's a good way I like to think of it. Integer begins with the letter I, and I say it this way: I like integers because I hate fractions. Fractions and decimals are annoying. Would we all agree? Show of hands if fractions and decimals are annoying to you. Good, we're going to go along great this year. We hate fractions and decimals. We have to work with them from time to time, but it doesn't mean we have to like it. Agreed? All right? I like integers. They're nice, easy numbers. They make me smile. Okay? I like integers. I don't like fractions and decimals. So if it's got a fraction or decimal, it ain't an integer. If it doesn't have a fraction or decimal, it is an integer. And 112 doesn't have a fraction or decimal, so is it an integer, class? Yes, because it's a number I would like. Look at number 2. Is that a counting number? No. Your mom is not going to count -67, okay? Is it a whole number? No, because whole numbers only include the counting numbers or natural numbers plus 0. Is it a positive number? No. Is it a negative number? Yes, it is a negative number. Is it an integer? Yes, because there's no fraction or decimal to it. Look at number 3, -4/5. There's only one thing you can mark, class.
Negative.
It's negative. It's not an integer because it's a fraction. Remember, I don't like fractions, I like integers. It's not an integer, but it is negative. That's all it's got going for it there. Put an X there. Do 4, 5, and 6 at the top of the next page. Do 4, 5, and 6 at the top of the next page. Mark all the boxes that would apply on 4, 5, and 6. All right, for number 4, there is only one box you get to put an X in. What is that one box, Sam?
Positive.
It's positive. That's all you can mark. It's not counting, it's not whole, it's not negative, it's not an integer, because we don't like decimals, remember? What about 0? For number 5, well, you could mark 2 boxes. What 2 boxes did you mark, Jalen?
Whole and integer.
It's a whole number and it's an integer. It's not positive or negative. It's the dividing line between the two of them. Number 6, 3.5. There's only one thing you can mark for this one, Elaine.
Positive.
It's positive. That's all it's got. It's not counting whole or integer. It's certainly not negative. Look at number 7. They got a little number line here. And on the little number line, they have 0 set way down here. That's okay. They've got -2 marked, and then, you know, they've got all their other numbers all the way up to 10. I'm going to be a little bit lazy here and not actually, oops, 10 goes there. I'm not actually going to mark all the numbers here. They want you to put a little dot everywhere we see a point. So the first number they want you to plot on number 7, right there in your textbook, is 3. So at your seats, find the 3 and put a dot on the 3, just like that. Okay, we're not trying to blow anybody's brain here. It's super easy. 5.7, where would that be, class? In between what?
5 and 6.
5 and 6, but closer to the 6. So put it closer to the 6, but between the 5 and the 6. Look at the next one, -1 and 3/4. Watch. Here's 0, -1, -1 and 3/4. As you go away from 0, it's just before you get to -2. If you're looking at it, you'd say it's just after the -2. But from the 0, just before you get to -2. Does everyone understand that? All right. And then the last one is 10. Put a dot at 10. Seem pretty easy? All right. Do number 9 right below it. Do number 9 right below that. Where did you put -6.1, Corey?
Close to the -6.
Close to -6, left or right?
Left.
Just a tiny bit to the left of -6. So as you're going from 0 just past -6. If you're looking at it this way, just before the -6 on the left side. What about 5, class? Don't make this hard. What about the 5? 5, put a dot there. What about 3 and 5/6? Where should I put that, Bryson?
Right here, in the middle of 3 and 4.
Between 3 and 4, but closer to which number?
4.
Really close to the 4. Not quite right up against it, but really close to that 4. And then -2, class, put it at the -2. Let's not. Don't you like integers? Do you see how easy integers are to plot? If it's not an integer, it's annoying. I like integers. Look at number 11. What's the absolute value of -6, class? 6, write that in the blank. What's the absolute value of 21, class? Write that in the blank. Number 13, what's the absolute value of a half? 1/2. Number 14, what's the absolute value of -45.3? 45.3. Number 15, what's the absolute value of -3/4? 3/4. Number 16, what's the absolute value of 4 and 1/9? Practically speaking, with absolute value, all it means is just ignore the sign and write the number down. Seem pretty easy? Look down at number 17. What symbol, greater than, less than, or equal to, should go in the blank for number 17? Sam? Greater than, because 12 is greater than 3. How about number 19? Jump over to number 19. What needs to go in that blank? Luciana? For number 19?
Equal.
Equal to, because the absolute value of 7 and the absolute value of -7 are both just 7, so they are equal to each other. What about number 21? What should go in that blank? Paige?
Equal.
Another equal to. How about number 23? What should go in that blank? Michael? Less than. 0.00245 is less than. By the way, you remember how to remember less than and greater than? Think alligator mouth. The alligator eats the bigger one. Okay, stay with me. Number 25. What goes in that blank then?
4.05
is
greater than.
Oh, is it? The other one also starts 4.05, but it's got a little extra tacked on, which makes it a little bit bigger, isn't it? So we should have a less than for number 25. Stay with me, I didn't tell you to back up. Number 27, what needs to go in that blank? Elaine?
Less than.
Less than. Remember, 4 and a half is a little bit less than 3/4, so we'll put a less than symbol there. All right, homework for this evening. Homework for this evening is to do page 11, numbers 1 through 13. Page 11, numbers 1 through 13. And on page 16, page 11, numbers 1 through 13. And on page 16, do numbers 31 to 48. Page 16, numbers 31 to 48. Let me say it one more time and I'll let you out of here. Page 11, 1 through 13. Page 16, numbers 31 to 48. All right, have a wonderful rest of your day, and you are dismissed.